Alright, so this podcast has to do with double replacement reactions. We were introduced to reactions and kind of balancing reactions in our last unit, and now we're going to look at a specific type. There's a number of types that we can kind of, narrow them down and kind of make sense of them, but one of them is double replacement reactions. We're going to start talking about solubility, and all solubility reactions are double replacement reactions, right? And they have this kind of format. We have some cation with an anion, so we're just going to call it AX, and we're going to react it with, let's say, BZ, okay? And the A, which is a cation, is going to switch partners, okay? So it is currently with the X anion, but it's going to be teamed up with the Z anion. So we make AZ, and in addition, we make BX, alright? So notice the cations basically switch partners. Therefore, it's called a double replacement reaction. The cations switch, the anions switch, and we have two new products. All right. So what you're going to need to do on homework in your lab is I'll give you two reactants. You need to predict what the products are going to be, and then in addition to that, balance the equation. So our first one's going to be, let's say we had magnesium bromide. Okay, and magnesium bromide is written like this. Why are there two Brs? Because magnesium has a +2 charge, bromine has a -1 charge. Okay, so to balance the charges we need two bromines. And we're going to react that with sodium chloride. Right, and why is that just written sodium chloride? Because sodium is a 1, chlorine is a -1. And I want to know, what is this going to make? Alright, in addition, I want to balance this equation. So one of my reactants, I'm going to have magnesium, but who is magnesium going to be with on the reactant side? Well, it was with bromine, so it's going to be with our other anion, which is chlorine. So we're going to make magnesium chloride. Well, how do you write that equation, or that formula? Magnesium is a +2, chlorine is -1, so we write it MgCl2. Additionally, we make sodium as our other cation. It was with chlorine, but now it's going to be with bromine. So we make sodium bromide. And again, to balance these, to find our formula, we need to balance our charges. Sodium is a +1, bromine is a -1, so that's written correctly. Okay. So now to balance my equation, as you can see, I've got one Mg on the left, I have one on the right. I have two Brs on the left, but I only have one on the right, so I need to put a 2 coefficient in front of sodium bromide. I have one sodium on the left. I now have 2 on the right because of the 2 coefficient, so I need to put a 2 in front of sodium. And I have two chlorines, and I have two chlorines. So this equation is balanced in a 1:2 to 1:2 ratio. Our next one, I would give you, for instance, calcium chloride and silver nitrate. Right, here's polyatomic ions popping up again, and again we're going to be balancing equations. So I've got calcium chloride, silver nitrate. One thing I can make is my calcium is no longer going to be with my chlorine, but it's going to be with my nitrate. So can I write calcium nitrate like this? I cannot, because we have to look at charges. So calcium's charge is +2, nitrate's a -1, so I really need two completely different nitrates. Alright? Additionally, I had silver as one of my cations, so it's going to start my next formula. It was with nitrate, but now it's with chlorine. Again, the question is, can I write silver chloride like this? I can, because silver is a +1, chlorine is -1, so that is completely fine. Alright, again, as we get a balance, I have one calcium, I have one calcium. I have two chlorines on the left, only one on the right, so I'm going to put a 2 right here. I have one silver on the left, but I have 2 on the right, so I'm going to put a 2 in front of my silver. And notice I really have two nitrates, or you can think of it as two N's and 6 O's, but I'm just going to think of it as I have two nitrate chunks. And over on the right hand side, notice I have two nitrate chunks. So again, my equation is balanced kind of like my first one, a 1:2 to 1:2 ratio. And our last one, if I had reactants of potassium hydroxide and calcium phosphate. Alright, so again, I would give you these things. If I give you formulas, you don't have to worry about checking checking to make sure the charges are done. You could if you wanted to. Potassium's a 1, hydroxide's a -1, so it's 1-to-1 ratio. Calcium is a +2, phosphate's a -3, so we need a 3-to-2 ratio. Alright? So as we move to the right, what things can we predict? Well, I'm going to take my first cation, which was potassium, and it's now going to be with phosphate. Again, can I write potassium phosphate like this? I cannot. Potassium is a +1, phosphate's a -3, so how do we write potassium phosphate? K3PO4. Alright, my other compound that I'm going to make is going to be calcium, because it is my other cation, but it's no longer with phosphate, it's now with hydroxide. So can we write calcium hydroxide like this? No, we cannot, because calcium is a +2, hydroxide is a -1, so I need 2 hydroxides for every 1 calcium. And as we go to balance this one, notice I have 1 K on the left, but I have 3 on the right, so I need to put a 3 in front of my potassium hydroxide. I have 3 hydroxides on the left, and I have 2 on the right. Oh, that's not good, because I'm going to do at least common multiple. So I don't really want my eraser here, because I'm really going to need to find the least common multiple of 3 and 2, which is 6. So I really need 6 KOHs. And over here I'm going to need 3 potassium hydroxides. Okay? And because I changed my potassium, I really need 2 potassium phosphates. So kind of as I revisit all this, I have 6 potassiums on the left, 6 on the right. I have 6 hydroxides on the left, I have 6 on the right. Moving on, I have 1 calcium, or 3 calciums, and I have 3 calciums. I have 2 phosphates, and I have 2 phosphates. So this is balanced 6-to-1 to 2-to-3. So again, the main focus on tonight, obviously a little bit of review of balancing equations, but writing double replacement reactions, and simply predicting what the products are going to be. They're always written cation first, anion second, and your people just switch, okay? Kind of like do-si-do, you're having a hoedown, and switch your partners, and you switch partners, and we're good.